Good morning, students. Today we will discuss Serret-frenet formulae. So there are three formulas. The first is derivative of t cap with respect to s is equal to kappa into n cap. The second is derivative of b cap with respect to s is equal to minus tau into n cap. And the third is derivative of n cap with respect to s is equal to tau b cap minus kappa into t cap. We have to prove these three formulas. In order to prove this, we remind that the vectors n cap, t cap and b cap, these are the fundamental unit vectors which are perpendicular to each other, and the plane which contains the two vectors t cap and n cap, that is the oscillating plane, and the plane containing n cap and t cap, that is perpendicular to the unit vector along the binormal. Now let us start the proof of first part. Now by definition, because t cap is unit tangent vector, so its magnitude will be 1. So now squaring both sides, we get t cap dot t cap, that is 1. Now differentiating both sides with respect to s by using product rule, we get this is 2 times t cap dot t cap dash is equal to 0, dividing third by 2. From here we get the dot product of t cap with t cap dash, that is 0. It means the two vectors, these are perpendicular to each other. Now we are to also prove that the vector t cap dash, that is perpendicular to the vector b cap. So in order to prove that, let us use the equation of oscillating plane. Now as you already studied that the equation of oscillating plane is given by the scalar triple product of the vectors r minus r, vector r dash and vector r double dash is equal to 0. Now because dr by ds, that is the unit tangent vector denoted by t cap, and r double dash means the vector t cap dash. So we can conclude from here that the vector t cap dash that lies in this plane, oscillating plane, and this oscillating plane is perpendicular to the binormal vector b cap. Thus we can say that the vector t dash, that is perpendicular to both t cap and b cap. Because it is perpendicular to these two vectors, so that will be parallel to their cross product, t cap cross b cap. So now t cap cross b cap is the vector n cap. So we can say that the vector t dash, that is collinear with n cap. Now the magnitude of the vector dr by ds, that is by definition curvature, which we denoted by kappa. So we can say that because the magnitude is kappa and the direction is along n cap, so we can write the vector t cap dash is equal to plus minus kappa into n cap. Now let us choose the direction of n cap such that the curvature is positive. So we can write the vector t dash in this form. Now from here, by definition of t dash means derivative of this t cap with respect to s. So this is equal to k into n cap. So this proves the first Serret-frenet formula. Now let us prove the second formula. In the second formula, we are to prove that the derivative of b cap with respect to s is equal to minus tau into n cap. Now in order to prove, we use the result that the vectors t cap, the unit tangent vector, and the unit vector along the binormal, these two are perpendicular vectors, so their dot product will be 0. Now differentiating both sides with respect to s, so by product rule, first t cap as it is, derivative of b cap with respect to s, plus फिर b cap as it is, derivative of t cap with respect to s, and this is equal to 0. Now using the first Serret-frenet formula, the derivative of t cap with respect to s, that is kappa into n cap. So substituting the value, now n cap and b cap are perpendicular vectors, so their dot product will be 0. So the equation reduces to the form t cap dot b cap dash is equal to 0. It means the vector b cap dash, that is perpendicular to t cap. Now we are further to prove that this vector is perpendicular to b cap also. So in order to prove this, we use the definition of vector b cap. Now what is b cap? That is the unit vector along the binormal. Because it is unit vector, so its magnitude will be 1. So b cap dot b cap is 1. Now differentiating both sides with respect to s, we get 2 times b cap dot b cap dash is 0. So from here, dividing by 2, we get the dot product of b cap and b cap dash, that is 0. It means these two vectors are perpendicular. So thus we can say that b cap dash is perpendicular to t cap as well as b cap. Because that is perpendicular to t cap and b cap, so that will be parallel to their cross product. Now b cap cross t cap is n cap. So we can say that b cap dash is parallel to n cap. Now we find its magnitude. Now by definition, the magnitude of b cap dash, that is torsion. So now this is the magnitude and the direction is along n cap. So we can write this vector b cap dash is equal to plus minus tau into n cap. Now from here, by using the definition, dash means derivative with respect to s. So db cap by ds is equal to plus minus tau n cap. Now according to our requirement, we take the negative sign. So db cap by ds is equal to minus tau into n cap. This proves the second Serret-frenet formula. Now we prove the third part. The third formula is the derivative of n cap with respect to s. We have to find this value. Now we use the definition of n cap. N cap is unit vector along the principal normal, which is given by the cross product of the unit vector along the binormal and the unit vector along the tangent. Now differentiating with respect to s. Now first function as it is, the derivative of t cap with respect to s plus derivative of b cap and cross में t cap as it is. Now by using the first two formulas which we have already proved, dt cap by ds, that is kappa into n cap, and db cap by ds is given by minus tau into n cap. Now because this is scalar, so b cap cross n cap, and from here n cap cross t cap. Now by definition, b cap cross n cap, that is minus t cap, and n cap cross t cap, that is minus b cap. So from here we have obtained the value dn cap by ds, which is given by tau b cap minus kappa into t cap. So these were the Serret-frenet formulas. Now next we find the curvature and the torsion at a point on a space curve in terms of the derivatives of the position vector r of that point with respect to parameter t. So firstly, let us find the formula for the curvature. Now if we take a point P on the space curve, then we can take its position vector as r vector and finding its derivative with respect to t. Now the derivative of vector r with respect to t is given by dr by dt. Multiplying and dividing by ds, we get dr by ds is the vector r dash and ds by dt represents s dot. Now by definition, dr by ds is the vector t cap. Now taking magnitude on both sides, because t cap is unit vector, so its magnitude is 1. Therefore the magnitude of r dot is s dot. Now differentiating this equation with respect to t. Now derivative of r dot with respect to t is r double dot, and from here by using product rule, t cap derivative is dt cap by ds and the derivative of s is s dot, and t cap as it is, the derivative of s dot is s double dot. Now by using the Serret-frenet formula, t cap dash is kappa into n cap. So we have substituted the value here. Now taking the cross product of these two equations. So we take the cross product, r dot cross r double dot, and on the right hand side also taking the cross product. Now because t cap cross t cap, that will be 0, therefore the cross product of r dot and r double dot is reduced to this value. Now by definition, t cap cross n cap, that is the vector b cap. Now taking magnitude on both sides, if we take magnitude, now b cap is unit vector, so its magnitude will be 1. So from here we get the value of the magnitude of the cross product of the vectors r dot and r double dot. Now we have already obtained that s dot is the magnitude of vector r dot, substituting the value, and from here we can find the value of kappa. So this is the formula for the curvature in terms of the derivatives of the position vector r of a point with respect to parameter t. In the same way, let us find the formula for the torsion. Now to find the formula for the torsion, let us differentiate the equation 4 with respect to t. Now from here, by using product rule of differentiation, r dot as it is, the derivative of r double dot is r triple dot, plus now derivative of r dot is r double dot and r double dot as it is, and also to find its derivative, now s dot cube into kappa, this is the first function and this is second. So first function as it is, derivative of b cap, plus b cap as it is, derivative of s dot cube into kappa. Now doing the derivatives and taking the dot product of equation 3 and equation 6, and using the properties of fundamental unit vectors, as we know that the fundamental unit vectors are mutually perpendicular to each other. So n cap dot b cap is 0, t cap dot n cap is 0, t cap dot b cap is 0, and the cross product of the vector r double dot with itself, that is also 0. So the scalar triple product of the three vectors r double dot, r dot and r triple dot is given by this. Now from here let us substitute the value from the equation 5. This value we have substituted from equation 5, and from here we can find the value of tau. Now next let us derive some another formulas for the curvature and torsion. Now next we prove that the curvature is given by the magnitude of cross product of r dash and r double dash. So in order to prove this, let us use the definition of both vectors. Now r dash is the vector t cap, and by Serret-frenet formula r double dash is given by kappa into n cap. Now taking their cross product, and by using t cap cross n cap is b cap. Now taking magnitude on both sides. Now b cap is unit vector, so its magnitude will be 1. So from here we have obtained the formula for the curvature. In the same way, let us prove the formula for the torsion. We have to prove this formula, that torsion is given by this. So in order to find this, let us find the scalar triple product of the vectors r dash, r double dash and r triple dash. R dash and r double dash we already have. Now let us find r triple dash. So let us differentiate r double dash with respect to s by using product rule. So kappa as it is, the derivative of n cap, plus n cap as it is, the derivative of kappa. Now by using Serret-frenet formulas, substituting the value of dn cap by ds here and dk by ds, that is kappa dash. Now from here we have obtained three equations. Equation 1 which gives r dash, second equation which gives r double dash, and third which gives r triple dash. Now we have to find the scalar triple product of the three vectors. So let us find the scalar triple product of the three vectors. So in the first row we write the components of r dash, which are 1, 0, 0. In the second row we write the components of r double dash, which are 0, kappa, 0. In the third row we write the components of r triple dash, which are minus kappa square, kappa dash, kappa into tau. Now expanding this determinant, we get the value of scalar triple product, which is kappa square into tau. So from here we can find the value of tau, which is given by this scalar triple product divided by the square of the magnitude of cross product of r dash and r double dash.